Our next lesson is called Domain and Range. We're going to start with an opening exercise. Identify the relations below that are functions. Explain your answer. So at this time, could you please pause the video, try questions 1 and 2, and then resume the video to go over your answers. Okay, now that you've had a chance to try the opening exercise, let's go over the answers. You were supposed to identify the relations below that are functions and explain your answer. So in number 1, this is a function. Each input matches to one output. I can see in the left-hand side circle, the input circle, there's only one arrow coming from each element in the input. It does not matter that A and C are both going to the number 1. That's not a problem. We're only concerned with each input having one output. So number 1 is a function. When I look at number 2, we have a couple of problems. The first one is the number 2 has 2 arrows. 2 is matched with B and with C. 3 is also in the same situation. 3 matches with D and E. So this is not a function. The inputs of 2 and 3 have more than one output. So at this time, you need to go to the Desmos activity on domain and range and complete slides 1 through 6. Once you have completed slides 1 through 6, it will prompt you to return back to your notes. At that time, you will resume the video and continue the notes with me. So right now, pause the video, go to your Desmos domain and range activity, and then come back to the video once you have completed slides 1 through 6. Okay, so now that we've learned a little bit about domain and how we're going to start finding that, let's actually define the domain of a function. So the domain of a function is the set of all inputs, underline that word, which are your x values. So domain is the set of all inputs, which is your x values. Let's use our function from above. We'll use both of them, the function and the non-function, just to write down what the domain is, okay? So in number 1, the domain is your set of inputs. The input circle is on the left, so that would be the list of A, B, C, and D. Make sure you use the curly brackets for set notation. In number 2, the domain or the inputs, again, are on the left-hand side. This time they are numbers. So they would be 1, 2, and 3. So again, domain of a function, the domain is the set of all inputs or the x values. So now at this time, you will pause the video again. You're going to return to your domain and range Desmos activity, and you are going to finish it by completing slides 7 through 10. It will then prompt you to come back to the video. We will define range and move on from there. So again, at this time, pause your video, complete your Desmos activity, 7 through 10 slides to finish, and then return to your notes. Okay, so now that you've investigated range a little bit, let's define the range of a function. This is the set of all outputs, or y values. So if I were looking at, we'll squiggle underline outputs here. If I was looking in number 1, my outputs are the set 1 and 2. If I was looking in number 2, the set of my outputs would be A, B, C, D, and E. So domain is your input or x values, range is your output or y values. One quick way you can remember that is by looking at the letter that it starts with, domain and range. Most people remember the words, but they don't necessarily remember which one is which. So try to think of it alphabetically. D comes before R, so domain comes before range, and X comes before Y, the same exact way alphabetically. So the ones that come first go together, the ones that come second go together. So now we're going to look at examples of finding domain and range for different types of functions, different representations. So in example 1, it says for each relation, determine the domain and the range. The first one we're going to look at is a graph. So when it comes to a graph, I want you to think about pinching the graph and trying to see where the boundaries are. We'll start with domain. When we're talking about domain, domain is the set of x values. So we're actually going to take our hands and put them in front of us and make them look like y-axes. So that means straight up and down vertical. And we're going to try to pinch the graph from the left and from the right. I'll show you with a highlighter to try to demonstrate the same thing. If you want to just watch first, please don't draw this. When I start coloring and try to come in from this side, I see that this arrow is really continuing all the way over here. So am I able to pinch on the right-hand side? I am not. The same thing happens when I try to come from this direction. I think I'm pinching, but again, this arrow is continuing on forever in this direction. So there's nothing I can pinch from that side either. So this graph is showing that this is going to continue to keep going up and out, which means I can use all of my x values. So here, the domain, remember, which is a set of all inputs or x values, are all real numbers. So the way we write that in set notation is with the funky R. And remember, that means all real numbers. Okay? Now, when we try to do the same thing for range, since range is the y values, I actually want to make my hands look like x-axes, which means I'm going to make them parallel to each other in front of me, and I'm going to try to pinch the graph from the top and pinch the graph from the bottom. You can also, again, use highlighters to help you do this. So for this one, when I try to start pinching from the bottom, I can. I get to this boundary, and I can't go any further. When I try to do the same thing from here, I see that the arrows would continue going this way and this way, so I cannot pinch on the top. Because again, the graph is going to keep going up and out. So this shows me that my y values are the number 3, -3, and anything above that. So my range in an inequality would be y is greater than or equal to -3. We also learned interval notation, so we'll write it in interval notation as well. This shows me that -3 is the lower boundary, and it is included, so I will use a squared bracket, and it's going to go towards infinity, which has an open bracket. So I would highly suggest for a graph that you use highlighters or colored pencils to help you determine this. And remember, you're trying to find the boundary around the graph. Now, when we go to our table of values here, this one's a little more like what we saw above in the mapping diagram. We know that our domain is the set of all inputs or x values. So I'm going to look at the x values of the table, and I'm going to list them. Now, before we do this, you will notice that there are some repeated values. There is no reason to list these twice. So I am going to list them from least to greatest. Also, that does not have to matter, but it does help you stay organized. I'm going to list my lowest one as a 0. Then I have a 2, I have an 8, and I have an 18. Even though they show up repeatedly, I do not need to list them more than once. For my range, I'll write that down here because you can see we have quite a few more values for our range. So for our range, we have -3, -2, -1, 0, 1, 2, and 3. Okay, so there's an example of listing a domain and range from both a graph and a table of values. Now let's move on to a list of coordinates. Very similar to a table, just organized in a different way. You know all coordinates are x first and y second. So my domain would be the set of all inputs or x values. When I look here at my x values, they're all 4s. So my domain is just the number 4. When I look at my range, I'm looking at the set of all my y values. So they are the numbers that come second in the coordinate. So my range is 0, 1, 2, 3, 4, and 5. Now, when we look at an equation, there's a few different ways you can tackle an equation, okay? When you are figuring out the domain and range for an equation, you definitely want to make sure that the first thing you do is the domain. Once you figure out what your inputs can be, you can take your lowest number input, plug it in, and you'll find the first number of your range. So for domain, we want to look at this function. I see that this is a square root function. So I know I'm not allowed to take the square root of a negative number. So looking inside here, I have to think about what number can I put in for x that will make sure it's going to stay positive. So I can have 0 and up. So what would make x minus 7 equal to 0? 7 would. If I put a 7 in for x, 7 take away 7 is 0, and I can take the square root of 0. If I put in anything less than 7, let's say 6, 6 take away 7 is -1. I cannot take the square root of a negative number. Okay, so this is coming from me thinking, okay, x minus 7 can be 0. That's the lowest it can be. So if I add 7 to both sides, I see that x is 7. So that tells me for my domain that x has to be greater than or equal to 7, or in interval notation, 7 is the lowest it can be, including 7, and going towards infinity with an open bracket. Now, what you would do next is use the domain to find your range. Now that I know 7 is the lowest it can be, if I actually did plug 7 in, 7 take away 7 is 0, the square root of 0 is 0. So now I know the lowest y value I can have is 0 and anything bigger than that. So my range is y is greater than or equal to 0, or in interval notation, 0 is the lowest and included, going towards infinity. Okay? So again, up here, any number smaller than 7 would make it a square root of a negative number, which is a problem. Now, the other thing you can do is actually use your graphing calculator to help you. So I'm going to put graphing calculator can help. So we're going to take a look at the graphing calculator right now. All right, let's go to our y equals screen, and we're going to type in our equation. We're going to hit second x squared, because that'll give us our square root, and we're going to type in x minus 7. We want to take a look at the graph of this. So remember, when we're graphing, we always want to hit zoom and then pick choice 6, which is standard. Looking at the graph, you can see we don't have any x values until you get over here past 6. Okay, and each of these blocks are going by 3. So this is about a third of the way. So that's where you see the 7. If it's hard to see from the graph, you can also look at the table. But looking at this, you can see my x values do not start until x equals 7. And I don't have any y values below 0. So you can make the graph on your graphing calculator to help you figure out the domain and range. You can also look at your table of values. So if I hit second graph, I'm looking at the table. You see a bunch of error messages. However, if I keep scrolling down, there's the first time I don't receive an error message. So it's telling you that your x values start at 7 and your y values start at 0. So that's another way you can help yourself with these equations trying to figure out your domain and range. So now lastly, let's look at the application. So in other words, a description or word problem. The assignment of students to physical education teachers. So we got to think about this. We're talking about the middle school. So what kind of students do we have in the middle school? We have grades 6 through 8. So each student is going to be assigned to a PE teacher. So the domain, which remember are our inputs, are going to be the set of grade 6 through 8 students. We're going to have to use a description in this case because we cannot list every single student that's in the middle school. So our input are grade 6 through 8 students. They are the ones that are going to be assigned to a teacher. The range then are the PE teachers. Our choices, we can actually list out for this, would be Mr. DeWolf, Mr. Latini, Mr. Lasher, and Miss Easton. So you can also find domain and range when you're talking about a description or a situation. The last application of domain and range I'd like to discuss together is example 2. Let f be a function such that f of x equals 2x minus 4 is defined on the domain 2 is less than or equal to x is less than or equal to 6. Find the range of this function. So this is an example of creating a graph where they have restricted the domain, and therefore your range will be restricted in a certain values as well. So this right here, domain is 2 less than or equal to x is less than or equal to 6, means that you only use x values from 2 to 6, and I'm going to write inclusive, which means the 2 and the 6 count. So the best way to do this is to take and use your graphing calculator. So we're going to go back to the graphing calculator and we are going to type in our new function. So we'll head to our y equals screen and we're going to clear out the equation that we had in there previously. And now we're going to type in 2x minus 4. That's our new function. We do want to see what the graph would look like. So we'll hit zoom and choose choice 6 for standard and get an idea of the graph. However, we only are allowed to graph this from 2 to 6. So we want to go look at the table by hitting second graph, and we only want to write down the values from x equals 2, which is right there, down to x equals 6. So we'll head back to our notes and record that portion of the table. So we know we have x and y. We are specifically using the values 2 to 6 inclusive, so 2, 3, 4, 5, and 6. And using our graphing calculator, we see that the y values are 0, 2, 4, 6, and 8. So we are going to graph it on that defined domain. 2, 0 is here, 3, 2, 4, 4, 5, 6, and 6, 8. Now when we connect these, it's important that we do not draw arrows. We are not allowed to go past 2 or past 6. So it creates a line segment, a portion of the graph. We'll still label it, knowing that our domain has been restricted. So finally, they want us to find the range of this function. We have now a picture of the graph. So we could go ahead and start shading like this and see that my lowest y value is a 0, and my highest y value is an 8. And therefore, we can list the range as being between 0 and 8. So you would have to write it as 0 is less than or equal to y, which is less than or equal to 8. If you were going to write that in interval notation, 0 is included, it's the lowest. 8 is included, it's the highest, and everything falls between there. So at this time, I would like you to move on to the practice section of the lesson. In the practice, you're going to circle the graphs that are functions and state the domain and range of each for numbers 1 and 2. Number 3 wants you to examine 2 equations and talk about the restrictions on the domain. Restrictions means what kind of numbers are we not allowed to use? Number 4 is a description, so you're going to use that description to answer questions A, B, and C. At this time, please pause the video, and when you're ready to go over the answers, you can resume the video to check your work. Okay, so you've had a chance to try the practice questions. We'll start with the graphs. Remember to use highlighters or colored pencils or use your hands to try to pinch the graph to try to help you figure out the domain and range. So for the first one, the circle, if I look at the domain, I'm looking at the x values. My x values only go from -1 to 6, up to 7. So for inequality, that would be -1 is less than or equal to x, which is less than or equal to 7. X should be sandwiched in between. In interval notation, that would be -1 comma 7 with squared brackets since the numbers are included. For range, you've got -5 to -1 with brackets around it, again, because those numbers are included. As an inequality, it would be -9 is less than or equal to y is less than or equal to 1. For graph 2, I have a low y value of -2, but my x's go on forever. So my domain is all real numbers, and my range is y is greater than -2. It never quite touches -2, by the way. If you use your graph to help you look at that, you can see that dotted line there is showing you it never really quite gets down to 2. So -2, sorry. So -2 is not included. So that's why we have y is greater than -2 or -2 comma infinity with open brackets. When we look at number 3, f of x says 1 over x. So in a fraction, we know that no 0 can be on the bottom. So for f of x, the value of x can't be 0. That would make it undefined. For g of x, you're looking at a square root. So we talked about this earlier. You cannot take the square root of a negative number. So the value of x cannot be less than 0. For number 4, let h be the function that assigns each student ID to a grade level. So the student ID number goes to a grade level. Assign each student ID number to the student's correct grade level. So describe the domain and range. The domain is the input. It's the student ID numbers. The range is the output, which is the grade level, all the way from kindergarten to 12. So I use an ellipsis to show you the continuation of the pattern. So I didn't have to write all of them in between, but if you listed them all out, that's fine. In letter B, record 4 ordered pairs that represent yourself and students in your group or class. So this is going to depend on who you talked to. The first number should be your ID number, but everybody's going to have the same second number because you are all in 8th grade. And lastly, Johnny says this is not a function because every 9th grader is assigned the same range value of 9. The range only has 4 numbers, 9, 10, 11, and 12. So he's clearly talking about the high school. But the domain has a number for every student in our school. Explain to Johnny why he's incorrect. So Johnny's looking at it backwards. It's okay to have a bunch of different inputs going to one output. If all the arrows are pointing to the 9, that's okay. What we don't want are multiple arrows coming from the input side. And we don't have that because there's a unique ID number that each one has, and each one is assigned to the grade level. So he's incorrect because each ID number matches one grade level, input and output, and that's the definition of a function. So that concludes your lesson on domain and range.